This video looks at how to add vectors using components. There are basically 4 steps to this process. The first one is to resolve each vector into its perpendicular components, so one horizontal and one vertical. Once you've done that, you can add the horizontal components for each vector together, add the vertical components together, and then the last thing is you'll find use the sum of those components to find the resultant using the Pythagorean theorem. Let's have a look at an example. So this is an example that we've looked at before. Plane flies 200 kilometers south, 40 degrees east, then turns and flies 450 kilometers north, 20 degrees east. And we will find the magnitude of the vector, this time by looking at components. So in order to look at components, what we'll do is we'll break this vector down. We'll break the first vector down into its horizontal and vertical components. So I'll just draw a rough sketch here of what that vector might look like. So we're headed south 40 degrees east for 200 kilometers. So something like this, say. So we know that this here will be 200 kilometers. We know that the angle in here will be 40. And when we say to resolve this into its horizontal and vertical components, what we really want to do is break this down so this vector has a vertical component kind of like this and a horizontal component kind of like this. So we have a triangle that we've just created. It's a right angle triangle because the vertical and horizontal are at 90 degrees to each other. So what we can do now is find the missing side lengths here. I'm going to call this vector A and call this one vector B. We could switch that around if we wanted to. So let's go through the process here of solving. I'll start with B. So we know by using some right angle trigonometry that B divided by the 200, so the opposite over the hypotenuse, has to equal the sine of this angle here. So sine 40 would equal the opposite over the hypotenuse. So B over 200 is going to equal sine 40. What we want to do now is just rearrange this for B. And when you do enough of these, you start to recognize what things are going to look like. And you might be able to skip that first step, but if not, that's okay too. And then we can plug that into our calculators, and we can see that the magnitude, I should put some magnitude bars here, because this is the magnitude of B. The magnitude of B is, if we plug that into the calculator, we get 128.6. So that is the horizontal component of our first vector. We're going to find the vertical component as well, so the magnitude of vector A, using the same sort of logic, except now this A side, this is the adjacent side to our triangle rather than the opposite. So A over 200 now is going to equal the cos of 40 degrees rather than the sine. So the cos of 40 is going to be the adjacent side divided by the hypotenuse. And again, we can just solve that for the magnitude of A, and we will get 200 cos 40. Plug that into the calculator, and we get that the magnitude of A is approximately 153.2 kilometers. All right, that process that we just did, we're going to repeat for our second vector. So our second vector was somewhere up here, heading 450 kilometers. This angle here was 20 degrees. This side length was 450, and we kind of get our horizontal and our vertical components. I'll just draw them in here so we can kind of see them. And we'll give them a name. We'll call this D. We'll call this C. Similar to what we did last time. So again, we'll break this into its components. I guess I started last time with the horizontal. So let's start with the horizontal this time. One thing to note here is that I don't have the angle inside the triangle, right? But I know that this angle is 20 degrees and this whole thing needs to be 90, so the angle in here needs to be 70 degrees. So in this case, now I have, trying to find this side length, D, that's the adjacent side. So vector D divided by the hypotenuse, which was 450, is going to equal the cosine. So be careful there. That's going to be the cosine because that's the side length that we have. And just 70. And then we can solve for d, the magnitude of d is equal to 450 cos 70. Plug that into the calculator, and we should get a magnitude of 153.9 kilometers. All right, and last one here is for c. So let's find the magnitude of c. Magnitude of c divided by, so c is over here, that's the opposite side, divided by the hypotenuse, which was 450. Opposite over hypotenuse should be sine. And just multiply both sides by 450. If we plug that into the calculator, we should get 422.9 kilometers. All right, so we've done the first step, which was to resolve the vectors into their components. The next thing is that we combine the horizontal and vertical components of each vector. And so I'm just going to grab a screenshot of what that might look like because it'll look a little bit neater. What we want to do essentially is this right here. Whoops. Let's try that again. Is this right here. So we're going to take the horizontal vectors and add them together, so B and D. And then we'll take A and C and add them together. Now notice A and C are headed in opposite directions, so be aware of that as well. And we'll talk a little bit about how that plays out shortly. Okay, so let's start by doing the horizontal. So the sum of the horizontal, try to fit this all on one page, and we won't lose anything. So the sum of the horizontal basically is just taking B plus D. We want to find the magnitude of B plus D. Well, that's just equal to the magnitude of B plus the magnitude of D. And we've already found those magnitudes. Let's see if I can highlight them here. D is here. B is over here. So we get 128.6 plus 153.9, which gives us a total of 282.5. All right, so that was our horizontal. Let's do the sum of the vertical. I have to be a little more careful here because the vertical went in the opposite direction. So the sum of the vertical, technically speaking, means that we want to take A plus C. So we want to add vector A plus vector C. And that should, in theory, be the same as adding in the other direction, C plus A. The reason why I wrote it that way is that C was the bigger vector and they head in opposite directions. This is what I was talking about earlier. Because they headed in the opposite direction, what we really want to do is we want to take C and subtract A from it. So that looks like this. Magnitude of C minus the magnitude of A. So again, it's really important to have a picture here so you understand when you're adding or subtracting, because in this case it's pretty obvious that we need to take C. If we're going to add A, we're headed in the opposite direction, so we need to subtract those two vectors. And I think I can highlight those here as well. Here's A. Here's C. We want to take C and subtract A. So that's going to look like 422.9 minus 153.2. And that will give us a total of 269.7. All right, we've kind of added the components. Our last step then is to find the resultant, and we do that using the Pythagorean theorem. Let me just grab another screenshot, and I'll show you what that looks like. Essentially, actually, you know what? I can just do it right here. I don't need a separate spot. Really, what we're trying to do is we're trying to find this vector right here. Well, we already know the length of this horizontal portion of the triangle. We know the length of this vertical. We just calculated it. So we're going to use that to find out our R. Here's our vector R, our resultant. Sorry, that's a bad looking R. Let me try that one more time. There we are. Okay, let's do it. So find R, just using the Pythagorean theorem. So the resultant squared is going to equal those two vectors that we just had squared, which were here and here. So equals 282.5 squared plus 269.7 squared. And when we add those together, we'll get approximately 152,500, just like we did last time. Now you might notice that if you take those numbers and square them and add them, you may not get exactly that. I kind of kept more decimals in my calculator, but if you didn't, that's okay. You'll get approximately the same answer. All right, that's the resultant squared. I want the resultant, so I'm just going to take the square root of both sides, and I'll get 390. Whoops, sorry about that. Jumping ahead here. We want to take the square root of 15,000. Sorry, 152,500. And that is equal to 390.5, which matches up with the answer that we had last time. Again, if you get 390.46, I think is that what you get if you don't round. That's pretty close. I mean, that's obviously rounds to 390.5. And that's how we can use components. So it seems like a lot, but the nice thing about it is that you only need to use right angle trigonometry, so you don't have to dive into the sine law or the cosine law with it.